Assalamualaikum and good day everybody. Let us now proceed into the new subtopic 4.2 Functional Groups and Homologous Series. What is functional group? By definition, functional group can be described as atoms or groups of atoms in organic molecule which characterize its chemical properties and enable it to react with specific ways. Before we get into the series of functional group, let me introduce you to its alkyl or aryl group notified by the capital letter of R. Alkyl group can be defined as an organic chemical that contains only carbon and hydrogen atoms, which are arranged in a chain derived from an alkene by the loss of a hydrogen atom. These are some examples of alkyl group. While aryl group is any functional group of substituent derived from an aromatic ring, usually an aromatic hydrocarbon, such as phenyl. Now we're about to learn classification of organic compound. They should include the understanding of classes of compounds, the name of functional group, and the general formula. First, we're going to have classes of alkene. Alkene is the hydrocarbon compound. It is the simplest organic compound composed only carbon and hydrogen. Alkene does not have specific functional group as it consists of a single bond in between carbons. It has the general formula of CnH2n plus 2. Next, followed by classes of alkene. A hydrocarbon compound consists of functional group of carbon-carbon double bond. It has the general formula of CnH2n. Next, we're going to have classes of alkyne. Another hydrocarbon compound consists of functional group of carbon-carbon triple bond with the general formula of CnH2n-2. Then, followed by the classes of aromatics with the functional group of aromatic ring or benzene ring with the general formula of C6H6. Classes of haloalkane or alkyl halide. Haloalkane form when an alkyl group R bonded to the functional group of X or halogen group. It has the general formula of CnH2n plus 1X. Then, the classes of alcohol form when an alkyl group R bonded to the OH functional group, or we call it as the hydroxyl group, with its general formula of CnH2n plus 1 OH or CnH2n plus 2 O. Phenol form when an aryl group bonded to the hydroxyl group, with its general formula of C6H5OH. Then we're going to have ether form when both alkyl group breached by an oxygen atom in between, known as the functional group of alkoxy. It has the general formula of CnH2n plus 2O. Classes of aldehyde. Aldehyde form when an alkyl group bonded to a C double bond O functional group, or we call it as carbonyl group. This functional group of carbonyl should be exists at one end of carbon chain. It has the general formula of CnH2nO. Ketone form when a functional group of carbonyl exists between alkyl group in a carbon chain. It shares the general formula of aldehyde. Then we have a carboxylic acid form when an alkyl group bonded to the functional group of C double bond OOH, or we call it as the carboxyl group, with the general formula of CnH2nO2. Class of ester. Ester form when the functional group of carboalkoxy or C double bond OO exists in between alkyl group R. It has the general formula of CnH2nO2. Acid chloride or acid chloride form when an alkyl group R bonded to the acid chloride or acyl halide functional group of C double bond OCl. It has the general formula of CnH2n plus 1 COCl. anhydride. Anhydride form when a functional group of anhydride C double bond O or C double bond O exists in between alkyl group R. It has the general formula of CnH2n plus 1 CO2O. Class of amide. Amide form when an alkyl group R bonded to the functional group of carboxamide or C double bond ON with the general formula of CnH2n plus 1 CONH2. Amine form when alkyl group R bonded to functional group of amino or NH2. It has the general formula of CnH2n plus 1 NH2. Next, we have nitrite. Nitrite form when alkyl group R bonded to the cyano group or C triple bond N. It has the general formula of CnH2n plus 1 Cn. Now, let us identify the functional group in the following molecule. On A, we found only one functional group available. It is carbon-carbon double bond. While on molecule B, we found there are two functional groups available. They are carbon-carbon double bond and hydroxyl group. Now, let's identify all functional groups available in this complex structure of an organic compound. Here we have carboxyl group. Then we have anhydride groups, hydroxyl group, carboxamide group, carboalkoxy group, carbon-carbon double bond, and amino group. Homologous series. Homologous series is a series of compounds where each member differs from the next member by a constant CH2 unit or 14 mass unit, or some other book might call it as the methylene group. Members of the same homologous series are called homologs. These are general characteristics of homologous series. Homolog has similar general formula. Successive members of homologs differ by the number of methylene groups. Physical properties of homologs change gradually as methylene group increase. Homologs may have similar chemical properties, and homologs may be prepared by similar chemical method. These are general formula of some homologous series. This is an example of homologous series of alkene and cycloalkene. Here we found that each homolog is differentiated by the number of CH2 or methylene group. Here is yet another example of homologous series of alkene and cycloalkene. Again, we found that each homolog differed by the number of methylene group. From previous example, we know that alkenes and cycloalkenes belong to the same class of compound, but though they are from different homologous series. Hope you understand the information that we have gone through. Make sure that you answer the formative assessment right after. Bye for now.